So in order to calculate the actual and theoretical Coriolis component of acceleration, I required only three things from the experimental setup. First is the RPM at which that motor is rotating. It will provide me the omega. Q, the discharge. With the help of discharge, I can calculate velocity. And F, that is the force, spring force I required, through which I can calculate the torque. Now, let us just see how we are going to measure these three things from the experimental setup. I can get the RPM here. I can measure the RPM. I can change the RPM of the motor through this dimmerstat, first thing. So I can get RPM. At this RPM, I can measure the flow rate, discharge rate. So it will provide me Q. And here at the downside, you can see at the motor, we have mounted the spring balance. So this spring balance is connected with this motor. It will provide me a torque. So it will provide me force. Through that, I can calculate the torque. So these three things we are going to note down during the experimentation: RPM, discharge, and the force, spring force, through which I can able to calculate the theoretical and actual Coriolis component of acceleration. So let us just start the setup and take the readings, please. So we have turned on the main power supply. Now we are turning on the motor. So motor is on. Now we are going to set the discharge Q. So how much we are setting? How much it is?
750.
Now at the moment it is 750 liter per hour. Is that correct? Okay. Now for this 750, अगर आप ये ऑन करोगे ना, अभी ऑन मत करो, रुक जाओ. Now as I have explained you that how this experimental setup is there. So this is the pipe. There will be water flowing into this pipe. Now we will going to change the RPM of the motor. I have turned on the power supply to the motor. Now we will start giving the RPM to the motor, means to this pipe. So it started rotating, and simultaneously you can see the water jet is coming out from that pipe. So you can see pipe is rotating and water is following. That water is rotating as well as flowing linearly. So both motions are there. So here we need to calculate the Coriolis component. Now what we are going to do is we are going to measure the three required things. So this is the RPM. Let me just increase the RPM now. At this time, at this point of time, it is rotating with 17 RPM. Let us just set it to the, say, 50 RPM. Okay, so we have set it on the 50 RPM. You can see now. So 50 RPM is set. Water jet is coming out of that pipe. Now we will measure the Q. How much it is? 750. So the top end of that rotameter, we will going to see that top end, and that will be a reference point to measure the reading, to note down the reading. And then we'll see a spring balance force. So at this point it will be very difficult to see. Let me just increase the RPM just in order to get the spring balance movement. Now you can see slowly if I go on increasing the speed, you can see the fluctuation in the spring balance. You can see a movement of the spring balance. It means now the force started increasing. You can observe now. Here. Right? So from here we are going to measure the spring force. So it will provide me a torque. It will provide me Q, and here I got the RPM. So in the same manner we are going to repeat it 4 times. We'll note down the 4 different readings, and then we're going to calculate the actual and theoretical Coriolis component of acceleration for the different RPMs. Thank you.